It's part 3.3 of optimization problems. This will be the last part, so there'll be no more videos after this for this specific topic. Maybe, we'll see actually. Okay, anyways, so first question. All the questions from here are going to be the hardest questions from around the end of the worksheet. The worksheet will just be in the comments, I'll leave a link to it. So we've got this triangle here, and then we have this rectangle within it. We're told that AB equals AC. So where is it? AB equals AC, so it's an isosceles triangle. And we're also told that BC equals A, and then it's this altitude here. From A, we'll call it to M. Okay. One second, sorry. Yeah, okay. So BC equals A, M here, and we'll just call that X. It doesn't matter what you call it. So we can say that this triangle has area half mx squared because it's half base times by height. Okay, we'll end up changing that later. It doesn't really matter for now, as long as you just have some kind of like idea as to what the area is. And we can say that MC is therefore half X, right? Because if this full thing is X, then MC is going to be half X. MS, we'll just call this L for the length, and we'll call RS H. Okay, we'll just leave that there. We can reference it later. Okay, so I'm gonna just focus on, like, imagine this full triangle here. Just split it down the middle from A down to M. Okay, and just focus on this right hand side. Okay, it doesn't matter what side you pick, but this is just the way that I did it. So focus on this right hand side, and then you've got this rectangle here, and then you've got this larger triangle. It'll look like something like this. If you remember, MC is a half X, so this full length here is a half X. That's because BC was X. And then the height here would be X, because BC equals AM, so this is X. Okay, we called this L, and we called this H. Okay, so say we were considering these two triangles, we'll consider this larger one here. Okay, and we'll consider this smaller one here. It doesn't actually matter whether you pick this one up here either. But the only reason why we're doing this is so that we can somehow relate, these variables together. So if we imagine this smaller triangle here, if this is L here, then this length here is going to be a half X subtract L. So this is half X minus L. It still has height H. It has height H because this is H. Okay, and then this is just the larger triangle here. So this is half X, and then this is X. Okay, these are similar triangles, so we can say that half X minus L divided by half X equals H divided by X. You'll get that. The 2 comes up, so you'll get X minus 2L over X equals H over X, like that. Multiply by X on both sides, so it just cancels. So you get X minus 2L equals H, and we'll just leave that there, okay? We'll use this later. We can say that the area of PQRS is 2LH. Now remember, M was just a word midpoint here. MS was L, so that means PS is 2L, and remember RS is H. So 2LH is the area of PQRS. We know what H is, it's this, so we'll just plug that into there. You'll get this, so you'll have 2LX minus 4L squared. Okay, and now this is where the differentiation part of the question comes into it. We want the, what does it say? The largest, so we want to differentiate this, and then we want to show that it's the maximum, okay? It'll have a stationary point. Just obviously look at this. So this is an upside down parabola. And if we're going to have a stationary point and we want a maximum value, it's going to be at the turning point here at the top. Okay, so we'll differentiate this. We'll set it equal to 0, and then we get that 2x equals 8l, or x equals 4l. Okay, we can just plug this back into here, because this value of x maximizes PQRS. So we'll get this. This is 8l squared minus 4l squared, which is just 4l squared. And then the area of this full triangle ABC, remember we said it last time, it was a half x squared. Well, we know what x is now, it's 4l, so we can say it's half 4l all squared. This is 16l squared, 16 divided by 2 is 8, so this is 8l squared. This is obviously in the ratio 1 to 2, therefore area PQRS is half of area ABC. You might just want to pause and have a look at certain things, just go at your own pace. A right circular cone of radius r and height h is to be cut out of a sphere of radius r. Okay, so we've got this sphere here, okay, and we've got a triangle within it. This blue line here is the radius of the sphere, and it's capital R. Okay, so we can say that the volume of the sphere is 4/3 pi r cubed, and so the volume of this cone here within it is going to be 1/3 pi r squared h. Okay, and now we can just start labeling stuff onto here. So the radius of the cone is going to be lowercase r. Okay, and we can call this is the height h. Okay, that's this full thing here, and then we have this line here, which is capital R. If we look at this triangle here, okay, it's gonna have this bottom length as r, and it's gonna have this as capital R because that's just the radius. Okay, and just be careful here. So this here is going to be h minus r. Okay, because from here to here is r. Sorry, no. Sorry, from here to here is r. Okay, and this full thing is h. Okay, actually, you know what? You could just do Pythagoras on this if you really wanted to, but this here is just h minus r. Okay, so it's this full length. It's this full length minus the radius of the sphere. Okay. Now you can just use Pythagoras on this. So you got r squared plus h minus capital R all squared equals r squared. Expand this. So this is I'm not going to expand that in my head, but you know how to expand this. You'll get this, and we'll just leave that there for later. You could square root it to get what r is, but it doesn't really matter because if you notice here, some of the things that we're working in terms of are just already r squared, so there's no point of square rooting it here just to be able to square it back later again, so you can just leave that there. Okay, so we can just put this into there now that we related these variables. The reason why we wanted to do that is so we can get uppercase R with uppercase R in both of these, and that'll be helpful for later, and then we can find out what h is later. So we'll just plug this into there for r squared. We'll get that, and you can just you can just expand this out, so you can distribute the h, and it doesn't really matter whether you distribute the pi or not. I don't think I did. I might have, I'm not too sure. Anyways, we're going to differentiate this. What do we want? The max, we want the maximum volume of the cone. So if there's if it's a maximum volume, it's going to have a stationary point, and we want the top. So we want the maximum point. Okay, so if we differentiate this, you'll get 4/3 pi h capital R minus h squared pi. That's while obviously multiplying against this fraction here. So you'll get that equals 0. Add h squared pi to both sides. Is that not what I did? What did I do? Oh, okay, so I multiplied by 3 and then I added oh no, I didn't. I just factorized that. It doesn't matter. You can do either way. But anyways, you'll get here. Either way, you'll get that 4r equals 3h because that's one possible value. That's one possible solution to make this equal to 0. H could also equal 0, but you can't have a height of 0. So we know that 4r equals 3h. Okay. Now we can say that h equals 4/3 r. Now this is useful because we had our volume in terms of h and capital R, and now if we plug this, and now we have h in terms of capital R, so if we plug this into there, we can get the volume of cone just in terms of uppercase R, and then we can relate that to the volume of the sphere. Okay, so we'll just plug this into here. It's a bit messy, but it's fine. So we'll get here 8/3r, 8/3r squared. What is this? Minus 16/9 r squared, and then distribute 4/3 r across all of that. I don't know what that is. Anyways, if you just collect it all together, you'll get 32/81 pi r cubed. We want to show that this is a maximum. Oh yeah, I actually didn't say this, but it wants it in terms of capital R. Okay, so that's why we did all these steps with this and this. Okay, so we'll differentiate this again, and then we'll show that it's less than 0. Okay, so if we differentiate this again, you'll get 4/3 pi r minus 8/3, 8/3. R? Is that what I differentiated? Let me just check. Okay, never mind. Yeah, sorry. I differentiated this. My bad. Okay, yeah. So that's what I was doing. I think. Is it what I was doing? What was I doing? Let me see. Okay, never mind. Yeah, I just differentiated this, but I plugged in H into that. Okay, so that's what I did. You differentiate that, you'll get this, and then you need to show that this here is going to be greater than 0. I mean, if you look at it, what I said here. Okay, so this. Sorry, I had to say that it's less than 0. I don't know why I said it's greater than 0. That inequality is facing the wrong direction. That's my bad. But, you know, either way, it's going to be a maximum because this is less than 0. R is definitely a positive number because it's just a length. So this is definitely going to be positive. A positive multiplied by a negative will always be a negative. So this will always be less than 0. Therefore, it's a maximum. Apologies for that sign. It should be facing the other direction. Okay. A mobile phone wholesaler buys a certain brand of phone for £35 a unit and sells it to a shop for £100 a unit. Okay, so we've been given this first case. We'll just run through it, okay? So, in a typical week, the wholesaler expects to sell 500, and we'll just ignore this for now, okay? So let's see what the profit is. Well, if he's selling it for 100 and he buys it for 35, he's got £65 profit per sale. He sells 500 every week. So if we multiply this by 500, we'll get how much like profit he gets in a week, which is this. Okay, and so another way that we can, you know, say what the profit is, or like, you know, write the profit down algebraically, is 500. Okay, so how often it is? It's 500 in a week, and then it's the cost of the phone for the customer. Subtract the price, subtract the cost of the phone for the actual like wholesaler. Okay, and if you do this, you'll get the exact same thing as here. But this is actually more useful. This is the same 325, by the way. This is more useful because we can say now that, well, here, let's just see what it says actually. Let me, before I go into the explanation, showed that on a typical week, for every £1 reduced of the selling price of this phone, an extra 20 sales can be achieved. So we've got 500 sales right now, and then we can get an extra 20. But we can't just say an extra 20, we have to call it an extra 20n, or just any other variable. And the reason why that is because it's not always by 20, because you could reduce the price by £1 again, and then you'd get an extra 20 sales. So if we called it 20n, where n is the amount that you reduce the price, okay? And now the price, the new price, the old price was 100, but now the price is 100 minus n. That's subtract how much you reduce it. Okay, just this might be a little bit confusing at first. Just look through it, just look at it for a couple minutes, and it'll come to you. It'll make sense. This is the new price that they're selling it for after reducing the price, and for each like for every increment of n, that also affects how many sales there are. Okay, you can expand this. So you'll get 100 minus 35, so that's 65 minus n, and then 500 plus 20n multiplied by that. You'll get this, 32,500 plus 800n minus 20n squared. And we want to get the maximum weekly profit. So we want to differentiate this because it has, if you look at this, this is an upside down parabola. So there's a stationary point at the top where the value of n maximizes the profit. So we'll differentiate this. Constant, this goes away. So this becomes plus 800 minus 40n. That equals 0. So 40n equals 800, therefore n equals 20. You might be able to just see it from here. But anyways, n equals 20. Let's show that this actually is the maximum. So differentiate this again. So you'll just get minus 40. Okay, that's just completely incorrect. So that should say minus 40, not 800 minus 40n. Apologies. That is definitely less than 0. Therefore, this is a maximum. This here, literally just ignore this, because if you differentiated this anyways, again, you'd just get minus 40. Either way, you'd get the same answer. Just ignore this, and ignore this part here, and this. because this is definitely less than 0, therefore it is a maximum. Anyways, we get n equals 20. This is the value which maximizes the profit. We'll plug that into here, or into this one here, makes no difference. And then we'll just, actually, it's probably better if you're not using a calculator, just plug it into here, because it's a bit easier to multiply this out. So 20 multiplied by 20, and then 100 minus 20 minus 35, you'll get that. I don't know why that says 65. What, have I done something wrong? Let me just check. Let's see. Let's 35, 60. So he sells the firm for £35 a unit. 65 profits, £65 profits per sell. I think this I think I actually plugged this in wrong. Apologies for that. That should say 20 here and 20 here, I believe. Yeah, you should get 40,500. I don't know why I plugged in 65 into there. Is there a reason why I've done that? I made these slides quite a while ago, as you can tell. Yeah, apologies. I think that should say 20n in there, and then 20. I don't know why I put 65. Maybe I just wasn't paying attention. But the cost of the firm is going to be 100 subtract n, because remember here, this is the cost of the firm. We know that n equals 20, so 100 minus 20 will give us the cost of the firm that he should sell it for to maximize profits, and that'll be 80. Okay, let me actually just check back this over again. Let's see. Yeah, so I just went ahead and checked through the slide. It was supposed to be 20. I have no idea why I wrote 65 here, so I just went ahead and changed it. So yeah, that should be 20 there and 20 there, and you'll get 40,500. The rest of it's all the same. I also changed this just so that the second derivative was actually accurate. Either way, you'll get it's less than 0, therefore it's a maximum, and then the cost is 100 minus n, with n being 20, so it's 80. Okay, next question. This is, I think, the second to last. Oh no, sorry, we have 2 more questions after this, and then we're done. The figure above shows a hollow container consisting of a right circular cylinder of radius r and of height h. Okay. The cylinder is open on one of the circular ends, and the hemisphere is also open on the circular base. The cylinder is joined to the hemisphere at the open end so that the resultant object is completely sealed. Given that the volume of the container is V, this tells us that the volume is fixed. Okay, so it's you know, this will not vary, and we can use this as a constant later on maybe. Show that the surface area of the container is minimized when r equals h, and hence show further that the minimum surface area is this. Okay, so the surface area here we've got this like curved part around the cylinder. That's going to be 2 pi r h, and the reason why it is it's because, well, 2 pi r is just the circumference of a circle, and then 2 pi r h is like dragging it down, so that gives us the area around the outside, the surface area. And then we'll add pi r squared just for this bottom one, not for this top one, because that's, you know, that doesn't include the surface area. And then we'll have 4 pi r squared for the full surface area of a sphere, but then we want to half it just to get the top part. Okay, and that's our area. You can simplify that to get this. Okay, and we also want to find the volume, because the question, you know, hints at it here. The volume is going to be pi r squared h, so it's the area of this circle here, and then drag it down, so that's the volume of that part. And then the area of a full, sorry, not the area, sorry, the volume, and then the volume of a full hemisphere, of a full sphere, is 4/3 pi r cubed, and then so half of it will be half 4/3 pi r cubed. You'll get this. You know, this obviously simplifies this 2/3 pi r cubed. You can't collect these because there's a h there, obviously. What I'm going to do here is I'm going to multiply this all by 2. It might not make sense right now, but it will later. You can leave it as it is right now, but it'll just be easier for later. It makes no difference. So I've multiplied that by 2, and I'm also going to divide by r. Okay, and then I'm just going to subtract 2 pi r h, and then, sorry, no, subtract 4/3 pi r squared to get just 2 pi r h. And you might be able to see where this is going. This is equal to that. Okay, so we'll just plug this into there. Okay, so we've got that. We'll plug this into there. You'll get this. You can just remove the brackets. That's fine. What did I do? Yeah, okay, that's fine. And just just simplify it a bit. You'll get this for the area. Get it ready for. You can just differentiate it like this if you prefer. We're going to differentiate with respect to capital R. So just forget v. V is a constant, remember, because it's fixed. Okay. You can say that this is 2vr to the minus 1, or you might be just comfortable differentiating this normally, but this becomes minus 2v over r squared, and then this becomes 10 over 3 pi r. That's the same thing as what I said. This is going to be equal to 0 because it's either a maximum or a minimum. In this case, it's a minimum. Set that equal to 0. I'm going to just make this look normal, so minus 2v over r squared. Add minus 2v over r squared to both sides. Multiply by 3. What can we do? Multiply by r squared. You'll get this, and we'll just leave this here for now. We can simplify this just in a bit, but remember, so the volume was equal to this. Okay, we know what the volume is here. 6 times the volume is equal to this. This is 1 lot of the volume. So we can say that this 10 pi r cubed is equal to 6 lots of this thing here. Okay, so we'll plug this into there to get that. Distribute the 6, you'll get this. This obviously cancels it down. Pi r squared h, and then 4 pi r cubed. So you can just subtract 4 pi r cubed from both sides to get this. You can just divide by 6 here and divide by pi to get that, and then divide by r squared on both sides. R is not going to be 0 because it's a length, so you can do that. You get r equals h. So that's the first part done. Okay, and then show that it's minimized when this is true. So we need to find the second derivative to show that it is minimum. The second derivative is this. If you remember what the first one was, where is it? Here. Okay, so yeah, this is going to be positive 4 vr to the minus 3, and then this will just be 10/3 pi. So you'll get that. You can just say that this is 4vr over 4v over r cubed to get that. Remember, we got, where is it? We got this here last time, and we use this again because it's useful. The reason why it's useful is because we can say that we can use these in terms of a constant. And the reason why we want to do that, actually, I'll just show you. Okay, so if we divide by 6 on both sides to get this, and we'll plug that into there, this 3 comes down. Yeah, distribute the 4, this 3 comes down to get that. And if you notice here, the r cubes now cancel, and now we're just working in terms of constants. So we have a constant here and a constant here. You don't even need to add these together. You can just say, well, this is definitely greater than 0, therefore it is a minimum. And that part's done. And hence, show further that the minimum surface area is this. Well, that becomes trivial now. I mean, we already know. So we know that the area is this. We got this from last time. That was our 6v equals 10 pi r cubed. But this is just rearranged for v. We can say that r cubed is equal to, what was it? So 3v over 5 pi. And then we can just, you can cube root both sides. I don't think I did that. What I did was I factorized out a 1 over r on this side here. Because by doing that, first of all, you get rid of the r here. But this actually becomes an r cubed. And this is much easier to just substitute this into there. I didn't actually do it this way originally. But when I was having a look at the solutions to check my answers, I noticed that whoever wrote the solutions did it in this way. So I decided this will be this is a nicer way to do it. So I did that. So I just factorize that 1 over r. So this becomes an r cubed. You can just think about it. So r cubed over r, it will give you back r squared. So this is exactly the same as that. Now you can plug this into there. You'll get this. This becomes 15v multiplied by pi over 15 pi. That literally cancels down into just v. This cancels with that cancels with that, this cancels with that. You've got 2v plus v, so that's 3v multiplied by 1 over r. So, just bring this up here, you'll get that. We got this originally. There's not really a point of making this, doing the same thing as we did up here with this, because if you look at this, this wants it to be cube rooted, so we'll just cube root this to get that, and then now we can just plug this into there. You can simplify this, so this full thing here is like saying 3v multiplied by all of this to the power of minus 1 over 3. Obviously that's just because it's a reciprocal, so it brings this down here. Now this becomes, actually no, I didn't do that. What I did was I cubed this, so this becomes 27v cubed, okay, but I also cube rooted it, okay, and I just left the cube root as 1 over 3 here. The reason why I did that is because well, I'll show you. So you've got this. You can just swap these two around and get rid of the negative sign. And now we can multiply these together because they've got the same powers. Okay, so 27v multiplied by 5 pi over 3v. 27v cubed kind of cancels down with 3v, so that becomes 9v squared. Okay, I've not cancelled it yet, but that becomes 9v squared multiplied by 5 pi. Okay, I've still not cancelled it yet. 9v squared multiplied by 5 pi, that becomes 45v squared pi, all to the power of a third. This is the same thing as that, just to show that you've done the cube root sign, and that's it, done. This is the last question, I think. A rectangle ABCD is such that DC equals 6 and DA equals 4. So just draw a diagram. This is our rectangle. We've got AB, and then we've got C, and then D. Originally I did it as ABCD, but I realized that as I was doing the question, it made more sense to do it in this way, because you'll see why. Try it labeled however you want it to be labeled, and you'll notice it's just a bit of a hassle trying to do it in the other way, because you'll have a diagram maybe like down here or down there, and it's just annoying. So I've labeled it like this. You extend DC and you extend AD, and then you say that you connect this point here with that and that, so it's a straight line. So you basically just get a triangle. This is the point E here, and I think this is the point F. Yep. So DC equals 6, this equals 4. And now we'll just use similar triangles again. So we can say that. So we'll have a look at this triangle here. We'll call this length CFX. We don't know what that is. And we'll call this length AEY. Okay, so if we look at this triangle here, we've got this length here is Y, and then this length here will be 6. Okay, because this length DC is equal to AB. And then we'll have a look at this triangle down here. This one here, and we'll say that's X, and then this will be 4. Okay, and now you can relate these, so you can say that 4 divided by Y equals X over 6. These are similar triangles. You'll get that. So 24 equals XY, or XY equals 24. We can say that the area of this full triangle is half base times height. Okay, the base is going to be 6 plus X, and the height is going to be 4 plus Y, or Y plus 4. We know what XY is, so just rearrange for one of them. It doesn't matter which one. I rearrange for Y. Plug that into there to get that. You might, maybe just use a calculator if you want, but this isn't actually too nasty to just do normally. So distribute this. So this becomes 12 over X plus 2, 12 over X plus 4. I don't know why I've said plus 4 there. I'm pretty sure that's say plus 2. I just quickly amended that because that should have said plus 2, not plus 4. Obviously distribute the half across this and that because you're adding, not multiplying. Just expand this. Just do it very carefully. You'll end up getting this. You might say that it's all of this is over x squared, so you'll have 2x squared and then 72, and then 24x and then 72. Yeah, and then 72. You'll get the same thing. It doesn't really matter. This is just some of the information from last time we had that as the area. I think I actually forgot to animate that bit. It doesn't matter. We want this to be a minimum. Okay, so we'll differentiate it. It's got a stationary point because it's a minimum. So it's not obvious here, but this is actually going to be a parabola. And then the bottom of it, that value of x, which gives us the stationary point here at the bottom of the parabola, will minimize the area. So differentiate it, that's why it's equal to 0. Add 72 over x squared on both sides, multiply by x squared divided by 2. So x squared equals 36, x equals 6. Now we can plug this into there, because this is the value of x, which minimizes a. 72 over 6 is 12. 2 multiplied by 6 is 12. 12 over 12 is 24. 24 over 24 is 48. Now to show that this actually is a minimum, differentiate this again. This is 72x to the minus 2, and we have minus 2 multiplied by minus 72, so it's positive 144 over x cubed. Plug in x into here. This is straight away just going to be greater than 0, so it is a minimum. This would be 144 over 216. I don't think you actually need to show it, but this is just definitely greater than 0, therefore this is a minimum. I'm sorry for going quite quick. This was just a really long series, so I kind of tried to get through it a bit quickly. If you don't understand anything that I went over, maybe just ask me a comment in the questions, but just key things that I wanted to go over were, with any optimization problem, you'll almost always have to calculate the area, volume, or perimeter, okay? And you always, if you have multiple variables, always try and relate them. That's why you calculate two things. So you might calculate the area and the volume. The reason why you calculate both of them is so that you can relate some of the variables from one function to another, and that's really useful because it allows you to, actually solve the question. So always draw diagrams, and then just try different things. You might not get it right the first time. Most of these questions I had to put a lot of thought into them, especially the end ones, because these ones are difficult. But trust me, if you draw diagrams, it'll just become much easier. Try a couple methods. Similar triangles are a really good way to relate variables, especially on harder style questions. As you noticed, these NFU questions had a few questions where you had to use similar triangles. You might do it in other ways. That's just how I thought to do it, so that was just easier for me, I think. And yeah, that's pretty much it. So yeah, always draw diagrams. Always just calculate the area, the perimeter, and the volume. Maybe not the perimeter if there's no hint to it, whatever, whatsoever. So do that. Relate the variables. Just always differentiate. If you're in an exam and you get a question like this, just find anything and differentiate. You might pick up a mark or two, and then you might pick up another for relating some variables together. And yeah, that's pretty much all my tips for these types of questions. I hope you enjoyed. Thank you for watching, and that's all.